Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Pure Mathematics 1 for October, November 2024, paper 1-1. This is part 1 for questions 1 to 6. Question 1, this is coming from binomial expansions. In the expansion of kx plus 2 out of x all of it to the power of 4, where k is a positive constant, the term independent of x is equal to 150. We are told to find the value of k, and hence we determine the coefficient of x squared in the expansion. Now for binomial expansions, binomial means two terms, okay? So we are going to have the first term is going to be reducing this way. This n here is going to be the first power of this one here. So it will move from power 4, then 3, 2, 1, 0. And then the second one will move from 0, then 1, 2, 3, and then 4. Okay, now we don't need to waste time, okay, by expanding each and everything, and then we'll look out for that term that is independent of x. You just need that term independent of x. Term independent of x is going to be, you just write the combination, and then you write those two terms, kx, and then the other one is 2 out of x. Then you ask yourself, which power should I put here and also here, such that I get x disappearing. So you look at these pairs here, and of course that pair is going to be this one, 2, 2. Okay, so when I put here 2 and 2, I'll get k squared, x squared, and also we shall be having an x squared down, which will cancel. Okay, and then after that, now we can have this expanded. Now the power of this second term is always the one that we put here down. So I'll put a 2 here, and then here I'll have a 2, and then the n here, the power they have given you here. Okay, so we are going to have this is 4, then combination 2. You put that in the calculator. 4 combination 2, it will give you 6. And then when you expand here, you will have k squared, then x squared, then times 2 squared, that will be a 4, then over x squared. So I think you can see that x squared can go. And then our answer here, we get 6 times 4, that is 24. And then k squared. But they said that the coefficient of, the term independent of x is equal to 150. So that means I will equate this one to 150. So I will say 24k squared is equal to 150. And then our k is going to be the square root of 150 out of 24. So I first divide through by by 24, and then after I take the square root. Since I've taken the square root, it is supposed to be plus or minus, but they said k is a positive constant. So k here is going to give us 5 over 2, or you can write it as 2.5. Okay, and then next we are supposed to find, they said hence determine the coefficient of x squared. Now we need to find the term in x squared. Okay, the term in x squared is going to be equal to, we shall have a 4, then combination something, then remember we have our kx, and then the other one is 2 out of x. Then remember my pairs are here, so I'm supposed to look for a pair so that I put something here on this term and also here, and then it ends in x. Okay, it ends in x. That one has to be with a 3 and then a 1. Okay, 3 and a 1. So I'll put 3 here, then 1 here, so that I will have x power 3, then divide by x, which gives me x squared. So the power that is here, I'm going to put it down here. Okay, so I'll put 1 here. 4 combination 1 is a 4. Okay, that is a 4. So I write 4, then times k cubed, x cubed, then times 2 over the x. And then from here, we are going to simplify it. 4 times 2 is 8. Then we have k cubed and then x squared. Remember, our k is 5 over 2. So we cube it here and then we get that. So the coefficient of x squared is going to be this 8 times 125 and then out of 8, because 2 cubed is 8. Then this one will cancel with that. Then our answer becomes 125. Question 2. The curve y is equal to x squared minus a over x has a stationary point at negative 3b. Find the values of the constants a and b. Now, this point here, it being a point on the curve, that means it must satisfy the equation of the curve. So I can begin by substituting the coordinates here into the equation of the curve. So this is negative 3b. So y is therefore b, which is equal to x is negative 3 squared minus a out of negative 3. Okay, so this one will give us our b, which is equal to 9, then plus a over 3. This is one equation. Then they also said that this point here is the stationary point, and we know that for stationary points, dy dx is equal to 0. dy dx is equal to 0. So we need to differentiate. Our y is x squared. You take this one, the x up, it will be minus a, then x power negative 1. So that means the dy dx from here, you drop the power and reduce it by 1. So this is 2x. Then when you drop the negative 1, it will make this one a plus. So plus a, then x reduce negative 1 by 1, it will be a negative 2. Okay, so this therefore implies that I will have 2x plus a. I can write this as over x squared, then I equate it to 0. Now I'm supposed to solve this equation here. I can just multiply everywhere by x squared. So when I multiply by x squared, I'll get 2x cubed, then plus a, which is equal to 0. Okay, and since this one is a stationary point, already we have the x coordinate. The x coordinate is negative 3. So I can substitute here negative 3, then cubed plus a is equal to 0. All the power of a negative is always a negative. 3 cubed, that is 54. So, 27 times 2, that will be 54. So we shall have negative 54 plus a, which is equal to 0. Therefore, our a is going to be equal to 54. Now, after this, we can substitute into equation 1, okay? We substitute into equation 1. So substituting into equation 1. We have our b, which is equal to 9, then plus a, which is 54, then divide by 3. Okay, 54 divided by 3, you will get 18. And that therefore means that our b is going to be equal to 27. 9 plus 18 is 27. Next, question 3 comes from circular measure. The diagram shows a sector of a circle, center O, where OB is equal to OC is equal to 15 centimeters. The size of the angle BOC is 2 over 5 pi radians. Points A and D on the lines OB and OC respectively are joined by an arc AD of a circle with center O. The shaded region is bounded by the arcs AD and BC and by the straight lines AB and DC. it is given that the area of the shaded region is 209 over 5 of pi centimeters squared. Find the perimeter of the shaded region. Give your answer in terms of pi. Now, when we are finding perimeter, it is just summing up the lengths around the given shape. So we need this one here, we need this one here, we need the length of this arc, and we need the length of that arc there. So only the length of the shape. Now, since we are given the area of the shaded region, we are going to start from there. Okay, area of the shaded region is equal to area of sector, the big sector, OBC. Then we subtract area of the small sector, the unshaded one, area of the sector, OAD. Now, the shaded area is given as 209 over 5 of pi. Area of a sector, it is given in the list of formulae. When you check your list of formulae, now here I'm going to use my chapter summaries. Circular measure is here. Area of, so the area of the sector is a half r squared theta. Okay, a half r squared theta. Now, when we come to this one here, area of the sector, OBC, it's a half times the radius is given as 15, so we square that. And then times the angle is given here, 2 over 5 pi. So that will be 2 pi over 5. Then we subtract area of the sector, OAD, the smaller one, is going to be a half times, we don't know its radius, we don't know this distance here, okay? Then times 2 pi over 5 as the angle. Now, of course, these two can cancel this one here, and then this one also here. Even the pi can go because it is common everywhere, okay? So if we divide all through by pi, that one will go. Now, 15 squared will give us 225. Now, since the 2, by the way, since the 2 has gone, and everywhere now we see 5 is there, I can multiply everywhere by 5. That means here, the 5 will go, and I will have 209. Then here I'll have 15 squared, which is 225, then minus r squared. So my r is going to be the square root of 225, then subtract 209. So r for this case is going to be 4. So since I've gotten this one as 4, even here 4, that means DC, okay, DC, which is equal to AB, then shall be equal to the 15, then minus the 4. The whole of this is 15, then minus the 4, and this will give us 11. Then now we can come to perimeter of the shaded region. So perimeter of the shaded region, remember it is sum of the lengths around a given shape. Perimeter of the shaded region is going to be equal to the length AB, then we add the arc BC, okay, the length AB, then arc BC, then we have CD, and then AD, okay, arc BC, then plus the length CD, then plus the small arc AD. Now we are going to have AB as 11, then plus, remember, for the arc length, it is r theta. So the radius is 15. This BC here, BC, we have the radius as 15. So 15 times theta, which is 2 pi. So times 2 pi over 5. Then plus CD is also 11. And then arc AD is going to be r, then times the theta, which is 2 pi over 5. Then 11 plus 11, automatically that will give us 22. 22, then plus. Now 15 times 2 pi over 5, and also this one, I can put them together. So 15 times 2, that is 30 pi over 5. I'm not simplifying it because I can put it together with this one. Then plus 4 times 2, that is 8 pi over 5. That means I can have 22 plus 30 plus 8, that will be 38 over 5 pi. Okay, and they said give your answer in terms of pi, so the answer has to be this one here. Question 4, show that the curve with equation x squared minus 3xy minus 40 is equal to 0, and the line with equation 3x plus y plus k is equal to 0 meet for all values of k. Now, if I have a curve, let me just talk about maybe quadratic. If a line and a curve meet, for the quadratic, maybe it is U-shaped, they can meet at 2 distinct points. Okay, and here we say b squared minus 4ac is greater than 0. Then they can meet at only 1 point. That means this line here is a tangent. Okay, that means b squared minus 4ac is equal to 0. And then when they don't meet, that means b squared minus 4ac is less than 0. Now, if they say that the line with this equation and the curve meet for all values of k, that means we have to merge these two. They either meet at 1 point or at 2 distinct points. Okay, now for intersection, I will begin by saying for intersection because I'm solving them simultaneously. For intersection, I'll come to this one, x squared minus 3x, and then from here y is equal to negative 3x minus k. So I make it the subject and then I substitute it here. So where y is, then I put minus 3x minus k, then minus 40, which is equal to 0. Okay, then I open up the brackets, negative 3x times negative 3x, that will be a positive 9x squared. Then minus 3x times negative k, you will get positive 3kx. And then minus 40, which is equal to 0. So this one is simplified to 10x squared plus 3kx minus 40, which is equal to 0. Now, you don't need to write b squared minus 4ac is greater than 0 or greater than or equal to 0. No, you just need to find its expression. So what is 4ac? This is our b, this is our a, this is our c. So b squared, we are going to have 3k, we square it, then minus 4 times the a is 10, and then the c is negative 40. Then this one will give us 9k squared. Minus 40 times minus 40, that one will give us a positive 1600. Now, what we have gotten here, do you see that here we are having a k squared? Now, for all values of k, for all values of k. Okay, this 9k squared will always be greater or equal to 0. When k is 0, that will be 0. Whether you put a negative in here, any negative number you're going to put here and you square, it will automatically turn to a positive. Okay, so since this one is always positive, greater or equal to 0, that means our whole thing, the b squared, okay, the b squared minus 4ac, therefore b squared minus 4ac is greater than 0, because if this one is 0, there is the 1600, so it is always positive. So this therefore means that therefore the line and the curve okay, meet for all values of k. Question 5. The equation of a curve is such that the y dx is equal to 4x minus 3 root x plus 1. Find the x coordinate of the point on the curve at which the gradient is 11 over 2. Now the y dx is the gradient function. So that means I'll get my 4x minus 3 root of x plus 1. Then I equate it to 11 over 2. Then I can multiply everywhere by 2 to eliminate this denominator. So here we'll have 8x, then minus 6 root of x plus 2, then is equal to 11. So I'll get 8x. There are two ways we can do this, by the way. So this is 8x, then minus 9. If I bring the 11 this side, it should be minus 9. Then I can take this 6 root x on this side. So the one that has gotten the square root, you can put it on one side on its own, so that when you square both sides, okay, it disappears, the square root disappears. But if you leave it this other side, it will remain if it has another term with it. Okay, so we square both sides. When we square both sides, we shall have 8x minus 9 squared, then is equal to 6 root of x squared. When I square 8, the simple expansion of this one here is going to be, because we use this one here, a squared plus 2ab plus b squared. So you square the 8x, you get 64x squared. Then 2 times 8 times 9, you get negative 144 of x. And then you square the 9, you will get 81. And then this other side, when you square the 6, you get 36. When you square the square root, you will get the x. Then bring this one, this other side, you will get 64x squared. Then minus 180 of x, minus 144 minus 36, that is minus 180, and then plus 81, which is equal to 0. Now this is a quadratic. Okay, this quadratic, we can check whether it is factorizable. So I just bring my calculator, I press equation, and then quadratic is here, number 3. Then the coefficient here, the coefficient of x squared is 64. Press equals, then negative 180, press equals, and then 81, then press equals. So I get 9 over 4. So I'll write here x is equal to 9 over 4. Okay, and then the other one, x is equal to, you need to be very careful here. The other one, you just press here, that is 9 over 16. So 9, I write here 9 over 16. But if you just reach here and then you give these answers, you'll be crossed. So you have to be smart enough to show the examiner that you solved the quadratic equation, because there is a mark which is given for attempting to solve the quadratic equation. So what you can do, I can get the factors from which these roots are coming. Okay, so I can cross multiply, you will get 4x. Okay, you'll get 4x, then bring the 9. So it will be minus 9. You see that? Then I also come to this one, cross multiply. I will get 16x. Then bring the 9 here, minus 9. Then is equal to 0. Now, find the x-coordinate of the point on the curve at which the graph. Now, we have gotten two x-coordinates, 9 over 16 and 9 over 4. Okay? But one of them has to be wrong because they said the x-coordinate, it has to be 1. Now we check. We have to check them. So for x is equal to 9 over 4. Okay, what is the gradient? Remember, it is our dy dx. So dy dx, remember, it was given as 4x. Okay, 4, then your x here, and then minus 3, the square root of your x, which is 9 over 4, and then plus 1. Okay, so when we put this one in the calculator, it is going to give us, of course, 4 times 9 over 4, that one will give us a 9, then minus 3, square root of 9 over 4, 9 over 4, actually that is 3 over 2, 9 over 4, then next we have plus 1. So this one will give us 11 over 2. So this one gives us 11 over 2. So that means this has to be the answer. Okay? However, so our x here, write it here, x is equal to 11 over 2. You have to test and then you give the only answer that is needed. If we check this other one here, we have 4, okay, into the x-coordinate is 9 over 16, and then close the brackets, then minus 3, then the square root of 9 over 16, and then the next one is plus 1. So when you put there, you are getting 1. So that means this answer here, 9 over 16, is wrong. Okay. Alternatively, you could solve this equation like this. Alternatively, after this one here, from here, I can have 8x minus 6 root of x, then minus 9, okay, 2 minus 11, that is 9. Then I can let, it looks complicated, is equal to 0. I can let another letter, let's say y, is equal to that complicated term, root of x. That means when I square both sides, y squared is going to be equal to the x here, okay? Now, where there is x, you put y squared. So it will be 8y squared minus 6, then y minus 9, which is equal to 0. And then I just pull out my calculator here, and I do the same. So put mod, that is 5. Then you go to 3, that is quadratic. So the coefficient of y squared is 8. Then next is negative 6. Then the next one is negative 9. Press equals. So you get 3 over 2 and then negative 3 over 4. So you write y is equal to 3 over 2. And then also y is equal to negative 3 over 4. Remember, you have to show where this one is coming from. So cross multiply. This one is coming from 2y. Then take the 3 this side. So it will be minus. And then here we shall have 4y. Then take this 3 here. It will be plus 3 there. And then our x, remember, is equal to y squared. So you'll get 3 over 2 is square. And also the other x will be negative 3 over 4 is square. So here it gives you 9 over 4. And then here it gives you 9 over 16. You see that? And then you conclude that your x is equal to 9 over 4, like I've shown you before. Next, part B, they are saying, given that the curve passes through the point 4, 11, find the equation of the curve. To find the equation of the curve, I need to integrate, okay? So y is going to be equal to the integral of dy dx. You integrate it with respect to x. So we are going to have the integral of 4x. Remember, we are given 4x minus 3, then x power half. Root x is the same as x power half, then plus 1, and then with respect to x. When we integrate, we increase the power by 1. So 1 plus 1, you get 2, then divide by that new power. And then a half plus 1, you'll get 3 over 2, okay? And then you divide by that. Then plus, this one here is the same as x power 0, so increase it by 1, divide by that new power. So you get x to the power of 1, and then you add a constant. We add an arbitrary constant because we don't know the constant which disappeared when they differentiated. Because every time you differentiate a constant, you get a 0. Like if you are differentiating 5, 5 is the same as power x. I mean, 5 times x power 0. So when you differentiate this one, you will have now 0, then 0 minus 1. So the moment you multiply with the 0 here, everything just disappears. Okay? So that is that. Now, we can simplify this and we say y is going to be equal to 2x squared, then minus, this is 1.5. 1.5 goes into 3 2 times. So that is 2x power 3 over 2, then plus x plus c. Now, to get the value of c, we are supposed to use a coordinate through which a line passes. I mean, through which the curve passes. It is given as 4, 11. So using that 4, 11, you put the 11 here. Then where x is, you can put the 4 squared, then minus 2. And then we have 4 power 3 over 2, then plus 4 c. So this one is going to be 2 squared is 16 times 2, that will be 32, then minus 4 power half, you will get 2, then 2 cubed, you get 8. 8 times 2, that will be 16, and then plus 4 plus c. So rearranging all of this, we shall have here 16, okay? Then plus the 4, that one will give us 20. So now c will be equal to 11 minus 20, which is equal to negative 9. That means the equation of our curve is going to be y, which is equal to, you conclude, okay? Y is equal to 2x squared minus 2x power 3 over 2, then plus x minus 9. So that is going to be the equation of our curve. Question 6 is coming from coordinate geometry, in particular circles. Circles C1 and C2 have equations x squared plus y squared plus 6x minus 10y plus 18 is equal to 0. And then this one, so this one is in the expanded format. This one is in the completed square format. Then they are saying find the distance between the centers of the circles. So between the centers of the circles, you need to get, of course, the centers. Okay, so the center for this one, remember the general equation of the circle is x minus a squared, then plus y minus b bracket squared, which is equal to r squared. So what is here and then here? The center is AB. Okay, remember it has to be minus. So if here you're having a plus, that means the b value is going to be a negative. Now, I'm going to also express this one in the completed square format as this one here. So we are going to complete squares on x and y. X squared, I can rearrange, plus 6x. Then y squared minus 10y. I can take the 18 this side. When I'm completing squares, already the coefficient of x squared and y squared are all 1. Then that means we are going to get the coefficient now of x, divide it by 2. We get a 3. Put it together with the x here. Then pop it out as a square here. The same thing you do here for y. So minus 10 divided by 2, you get minus 5. So I put it together here with y. Then I pop it out here as a square, which is equal to 18. So meaning I will have x plus 3 bracket squared, then plus y minus 5 squared, which is equal to 18. Now we shall add the 25 from 5 squared, and then we shall also add the 9 from 3 squared. So meaning we shall have x plus 3 bracket squared, then plus y minus 5 brackets squared, which is equal to oh, by the way, this 18 here is supposed to be a minus, okay? It is supposed to be a minus, sorry. So altogether gives you the 16. That means the center, okay, the center of C1 is, so here we shall have negative 3 and then 5, okay? And then the center of C2 is 9, negative 4. So the distance between the two centers now, distance between the centers is going to be the square root. Remember, we have the change in x, okay? Then squared plus the change in y, okay? And squared. It's the length of a line segment. So we shall have 9, then minus 3 squared, then plus minus 4, also minus 5 squared under the square root. Then after that, we can simplify it. So 9 minus 3, that one is going to be a 12, then squared, that is 144, then plus 81, okay, because this is minus 9, I mean minus 4 minus 5, that is minus 9. When we add all of these together, we get 225, okay? Then square root of 225 is going to be 15. So the distance between the two centers is 15. Then next they are saying P and Q are points on C1 and C2 respectively. The distance between P and Q is denoted by D. Then probably find the greatest and least possible values of D. Now, I'm going to do some two sketches here. I can have this circle here, and then I can also have another one here, okay? This is for C1, and this is for C2. The center for this one is 9, negative 4, and the center for this other one is negative 3 and 5, okay? Then I can connect these two centers here. So the distance in between those two is 15, okay? But we know that the radius of the first one, of C1, okay, the radius, we shall get the root of this 16 here, okay? Check this here, r squared. So the root of that, root of 16 is going to give us a 4, okay? It is going to give us a 4. So that means here we shall have a 4. And then the radius for C2, if you bring the 64 this other side, then we say square root of that 64 is going to be 8. That means I will come here and I write 8, okay? So from the center to the circumference, here it is 8. That means in between here, 15 minus 4 minus 8. In other words, 4 plus 8, you get 12. Now 15 minus 12, you get 3. So that means from here up to here, those are 3 units, okay? Now, we can also have another sketch. Sorry. I can also have this one here and this one here. Same sketch, okay? One is for the least, and then the other is for the other is going to be for the greatest. Now, the same thing. I have here 4 units. I have here 8 units. And this is 9, negative 4. This one is going to be negative 3, 5. Now, I'm going to extend this one here. I can extend to the circumference of the circle. Extend this one here. And also extend this one there. The same thing, extend this one here. And also extend this one there. I can even make it dotted. Just dotted like that. Now, remember also that as I extend, this one is also 4 units. This one is also 8 units. So the points PQ, they say they are on these circles. So P is on the C1. So P, for the list, it is going to be, I'm going to use these direct ones. So P can be here, Q can be here. That means this one will give us the least distance. You see that? The least distance. And then for the greatest distance, I will use this one here. For greatest distance. So I'm going to have now P should be this side and Q should be this side for the greatest. Okay, so that therefore means, let me write something here. Radius for C1, we have seen it is root of 16, which is 4. Then the radius for C2 is the square root of 64, which is 8. So least possible distance, okay, between P and Q, possible values of D. Actually, I can say least possible value. Let me just write what they have given me. Value of D is going to be equal to 15. Then we subtract. We are getting the whole of this 15. We subtract the radius here and the radius here. So 4 plus 8, which is actually 3. And then the greatest possible value of D is going to be equal to, now I have this 4 plus the 4. Already here we have seen it is 3. So plus 3 plus 8 plus 8. You see that? Or I can say this is the whole of it is 15. So if the whole of this is 15, then I say this 4 here, 4, then plus the 15, then plus this other 8 here. So you will have, this will be 19 plus 8, that will give us 27. So this has been it for this paper. Thank you so much for watching. I'll see you in the next part of this video. Please like, share, and subscribe if you find the content very helpful to you.